Okay, let's get started. Everybody knows next week is spring break, right? I don't have to remind you of that. So no class next week. I'm actually happy to see everybody. For the most part, everyone's here. I thought it was going to be like 6 people in here today. But it's a good thing you're here because we're going to be covering more of these optimization problems where we're actually using the calculus that we've learned to do something useful. Last time what we did was, and we've kind of developed this over the last couple of weeks, that if somebody gives us a function, we can find max and min. All right? Specifically, if we're talking about a cost function, profit function, or a revenue function, we can use the first derivative to figure out where we've got peaks and valleys on the graph, right? And we saw that last class. The last example that I did, we were given a price-demand equation, and we had to come up with the revenue, and then we were given the cost function. We had to come up we were given the price-demand, and we had to come up with the profit function, and then we used the cost function that was given to us to come up with the revenue function. Then we found the maximum revenue and all that stuff, right? That's what we ended with last time. Y'all remember that, I'm sure, right? It's like 48 hours ago. Today we're going to do two new types of word problems, and it's really not two, it's really one, but it's another maximizing revenue problem, but the problem is a lot different. The way it's worded is a lot different than what we've seen. This is it up here. And then after that, we're gonna try and tackle what's called an inventory control problem. All right, this one's a little bit involved. I was talking with the person who leads this class. Each math course has a lead instructor, and they're the ones who kind of like you go to for help. And I asked, do I really need to cover inventory control? They said it's optional, but I think it's like a really not useful, but like you can see this in the real world, like big time. So I think it's worth us at least looking at. So that's our plan today. So let's start out with this problem. I hope everybody can read that. Can y'all read that okay back there? Yes? Okay. So let's take our time and read through this. Maximizing revenue. When a management training company prices its seminar on management techniques at $400 per person, 1,000 people will attend the seminar. All right, so you got this company, they're going to be doing a seminar at some hotel. People are going to pay to go to it. If you ever become a professional out in the real world, a lot of times if you're, let's say, I don't know, your business, right? So I'm sure there's like seminars and stuff like that you can go attend to go learn stuff, right? So you pay to go to the seminar, right? And if they charge $400 a person for the seminar, this company is expecting 1,000 people are going to go. Of course, if that price is increased, right, then less people are probably going to go. Or if it's decreased to like 20 bucks a person, people are going to be, standing room only, right? So there's always some relationship between how much it costs to get in and how many people will attend. All right? So $400 a person, 1,000 people will attend. That's what they've determined. The company estimates that for each $5 reduction in the price, an additional 20 people will attend. So if they lower the price, they expect more people, right? That's what they expect. $5 reduction, 20 more people are going to show up. How much should the company charge for the seminar in order to maximize the revenue? Does that even seem possible to you? That we can figure out like the exact price we need to make the most money? See, because these seminars, these companies that throw the seminars, they're in it for the profit too. They want to make money, right? So they're trying to figure out what should they price this seminar at so that they can make some cash, right? Does that seem like they could do that? I don't know. To me, it seems odd that they could somehow come up with a price that would maximize the revenue just from this information, but we can. All right. So let's try and break this down. Let's do like a little table. Let's start just by thinking through this. If we have the price here, and this is the number of people that are going to show up, we know that if the price is 400, we should expect 1,000 people to show up, right? Agreed? That's what's given to us? Now, what does the next sentence tell us? Company estimates that for each $5 reduction in price, blah, 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 blah. So what else could I put on this table that would kind of help me see what's going on here? $3.95. So if I bring this price down by $5, I'm going to get 1,020 people there, right? Agreed? All right, and if I bring it down another $5, $3.90, I'm going to get 1040, right? So one side's going down by 5, the other side's going up by 20, yes? Now, let's talk about the actual revenue, the money they're going to bring in, right? Or, well, they're saying revenue here. We're going to assume that the revenue, they don't talk anywhere in here about cost, do they? Like how much it's going to cost them to run the seminar? So we're really going to be looking at the money that's going to come in is just, well, you tell me. The revenue should be what? So like if they price it at 400, they expect 1,000 people. How much are they going to bring in? 400 times 1,000, right? Yes? So in terms of words instead of numbers, the revenue is going to be the price we charge, right? Times the number of people. Y'all agree with me on that? The revenue will be how much we charge per person times the number of people. I'm going to put a dot here instead of an X. What we would like to do is determine this revenue function, or this revenue, as a function of a single variable like X. That way we can graph it and find its highest point. So we've got to figure out what's the X in the problem, all right? We've got to come up with the X. So since this is the first example, let me help you with this. Let X be the number of price reductions we do. All right, so we're the company, right? We're the people throwing the seminar. We want to know how to price things, right? So do we reduce the price by $5? That would be one reduction of price. Or do we reduce the price by $10? That would be two reductions. Or three or four, get it? So the variable in the problem is not how many people are going or what the price is. It's the number of reductions in price we're going to have. Understand? Okay. So can you help me determine what these two pieces are? This and this. We need both of those somehow represented where X is in these. So can you tell me what the price is going to be? But you have to include the X in there. So it's 400, that's 400. I mean, if we do 400, that's no reductions, right? What if we do one reduction? What is it?
Minus 5x.
Okay, so what's happening is our price should start at 400, but then we should subtract from that 5 times the number of reductions we have. Think through that. I'm going to erase this because I need the space. Do you all agree with this? The price, so our revenue is going to be, the price is going to be 400 minus 5x. And let's put that in parentheses. I want everyone to make sure you understand this. X is the number of price reductions, right? X is number of price reductions. So in this first case, how many reductions do we have? 0. So if I put a 0 right in here for X, what's my price? 400. Now if I do one reduction, right? One reduction, I'm going to put a 1 in here, and now it's going to be 400 minus 5, which is 395. So this right here is where we're getting that taking away $5 from the price each time. Make sense? Okay, now, how about, you sure that makes sense? Okay. How about the number of people that are going to attend? If I have no reductions, I have 1,000, right? One reduction, I have 1,020. Two reductions in price, I have 1,040. So it's jumping up by how much each time? 20. So what should this be over here, the number of people? 1,000 plus 20x. Do y'all see how that works? See, this is coming down by 5 each step. This is going up, plus, right? Going up by 20 each step. Clear? This is it. This is the money we're going to bring in, right? This is a quadratic function. If we multiply this out, we'll get a quadratic, and then we'll be able to find the max, and we'll be there, right? Understand? So let's do it. Let's multiply this out. I'm actually going to rewrite this as r of x equals, let's see here. Here to here, what's that? 400,000. And then here to here, we get plus 8,000x. And then here to here, minus 5,000. X, and then finally minus 100 x squared. There we go. And let me clean it up. And I'm also going to put it in descending order. I'm going to put the highest power of x first. You don't have to do that. I'm doing it because it's habit. 8,000 minus 5,000 is 3,000x. And then plus 400,000. There we go. With me? Okay, this is our revenue function. And what we want to do now is take what? I forgot. What?
You need to find the x's or the zeros.
What do you mean zeros?
Set it equal to 0.
Set what equal to 0?
The quadratic equation.
Why? What would that give you? If you're saying set this right now equal to 0, right?
I'll give you
That'll give you the x values where your revenue is 0. We don't want the x values where the revenue is 0. We want the x values where the derivative of the revenue is 0, right? That would be our slope of our tangent line. So we need to take derivative first. I mean, you could set this equal to 0 and you get 2 answers. But all that's doing is telling you where your revenue is 0, which we don't want. We want the maximum revenue. So let's take our derivative. Now we're finally to the calculus part, right? We take the derivative, we figure out where it's equal to 0, we do test points, and we should be good. So what is the derivative of this thing? Negative 200x plus 3,000. And we're going to now set that equal to 0. And that means we're going to set negative 200x plus 3,000 equal to 0. I'm going to leave the 3,000 on this side. I'm going to take the 200x to the other side so it makes it positive. I'm going to divide through. I think I'm getting 15. Yes? You get x is 15. So does that mean that we need, are we done? Like, what do I need to do right now? I need a number line, right? I need a number line. I need to test. I need to make sure this gives me a maximum point on my graph. So let's just check it real quick by doing a number line. I'll do it right here. We have 15, and then we pick some test points here. And those test points that we pick are any numbers we want to the left. So how about 0? That's a nice one to the left. And to the right, I'm going to go with 20. And where are those numbers getting plugged into? Derivative. Here's your derivative. So what happens if I plug 0 into this? I get 3,000. That's positive, right? That means my revenue function is going up over there. And then I plug in 20 into this, and if you do that, you're going to get a negative number. And that means my revenue is going down over here. And that means I do have a what, local maximum right there? But see, if the function only goes up and down, it's never going to go up and down again. We would have seen that somewhere here. So this is the only place we have a maximum. Yes?
What happens if it stays positive or negative the whole time?
If what stays positive, then we would have no local max or no local min, depending on, yeah. If it was positive, then that means there is no maximum. Which means there's something wrong. If this were the word problem and you got that, something's wrong. Because you should have a maximum. Okay. So we have a revenue. We have maximum revenue at x equals 15. Do you all agree? I'm going to write that down because we have not answered the question. Therefore, we have maximum revenue when x is equal to 15. Let's go back to the word problem. How much should the company charge for the seminar in order to maximize revenue? $15? This doesn't mean $15, right? This means 15 what? Price reductions, right? 15 price reductions. So let's go back to the formula that we had for the price. Do you remember the price when we rewrote it? The price we said was 400 minus 5x. We said it was going to be started out at 400, but then it's going to be 5 times, take away 5 times however many reductions you have. Right? We know what x now is going to give us that maximum. So we're going to plug 15 into that. 400 minus 5 times 15. 5 times 15 is what, 75? So you get $325. We good? Okay, so we need to charge $325 to maximize our revenue. The next question is, what is the maximum revenue? What is it? So how are you going to figure out the maximum revenue? You can plug it into the original revenue function. We had the original revenue function down, didn't we? So this part right here, this answer for this is this. But now to address the second question, we could put our revenue function, if you go back before we took its derivative, was 400 minus 5x. This is before I even expanded it out, right? This is what it was. Right, that was before I multiplied everything out, that was the original revenue function. Let's plug 15 into this. So if we plug 15 into the revenue function, we get 400 minus 5 times 15, which we already did, right? And then 1,000 plus 20 times 15. So 20 times 15 is 300, isn't it? That's 300?
Yes.
So 300 plus 1,000. And this one was 325. And this is 1,300. Somebody please on their calculator tell me what that is. 422,000. 22,500. There you go. Now, could you have plugged that 15 into the version of the revenue where it was already multiplied out? Yes? You could do that, right? But I did this actually for a reason. I wanted to ask you one more question. And I think you're going to be able to give me the answer just by looking at what's up here, if you understand what all this means. How much are we going to charge to maximize our revenue? $325, right? How many people are we going to expect to see there at that seminar? 1,300. See, that's why I did it this way, because remember, this was the price and this is the number of people that are going to show up. So here's my price. Here's how many people were expected to show up. All right? So if we go off of this model, this company is saying, look, we could charge more, less people are going to come. We're not going to make as much money. We could charge like dirt cheap, right? $100, come to the seminar, right? You're going to get a bunch of people. But that doesn't make it the most money you can make, right? It doesn't give you the most revenue. So this is the optimum solution. Optimum price gives you this many people. No other combination is going to be better than this one. Okay. Does that make sense? All right, I'm going to let you do one now. If my book works, I've been having problems here with this. It keeps freezing on me. Does anyone have the book with them by chance? You do? Well, you know what? That's not going to help because I need to project it. So hold on. I could write it, but I don't have my book.
About the Elmo thing, the little camera.
Yeah, the Elmo might work. We can try that. Let me see. Who has the book? Someone has them? Can I borrow it real quick? Thank you. Let's do the Elmo.
No way. Well, I had this book from last
Okay,
semester
let me,
because
excuse me.
so I just bought it last semester.
Okay, here's what I'm going to do for this problem. It is going to be turned in, but here's the deal, all right? To reward you for being here on the day before spring break, because I almost didn't want to come. I don't want you to, share this with anyone that's not here. I'm going to take attendance today. I expect only the people who are here to turn this in. At the day of the next test, just bring this, and I'm going to count it as a bonus question, like a bonus problem for you, okay? But if anybody else turns it in, well, what if they watch the video, though? Well, only the people who are here will get the bonus, okay? Let's do it that way. What's that?
Edit the video.
Edit the video? I hate editing videos. Takes too long. All right, so got that? So make sure this is on a separate piece of paper with your name on it. Put the date on there and turn that in at the test. Do not forget, okay? I'm only going to accept it on the day of the test. All right, let me get this thing going here. Where's that Zoom? There we go. And it's not very good, but let's see here. Can y'all read that?
Which one is it?
It's the match problem number 6.
Yeah, it's alright. It's like readable.
Can y'all read this? This one right here. Let's just read through it. A walnut grower estimates from past records that if 20 trees are planted per acre, then each tree will average 60 pounds of nuts per year. If for each additional tree planted per acre, the average yield per tree drops 2 pounds, how many trees should be planted to maximize yield per acre? It's basically the same problem you just did. Some things are a little different, all right? But I want you to work together and see if you can't figure this out, all right? And I'll give you, 15 minutes See what you can do? It's the one that's boxed here. Yeah, don't worry about this one right here. I wish I could get that image better, but
I think if you press the red button on the side.
this. Oh, I had there.
Yeah, there you go.
There you
That's a
go.
lot better.
It's supposed to have auto. Oh no, it says autofocus. Press the button.
Yeah,
That's better. Can y'all read that now?
it's a lot better.
Trying to make this a little better for you. There you go. Okay. Have fun. Talk to each other. Start with the table if you need to, okay? Just like we did in the last one. Start with the table. Try and figure out what's happening here. If one goes up, the other goes down, or maybe if one goes down, the other goes up. I don't know. I unmuted my microphone.
Let's try it.
You want to try what? Another one? Okay, well then look at example 7 here. Look at example 7. Let me move it up. But I have to be careful not to show you the answer. Well, here, we'll do this. That okay? Yeah. All right. So look at this. After additional analysis, the management training company in example 6, that was the one with the seminar, right, that we did, decides that its estimate of attendance was too high. Its new estimate is that only 10 additional people will attend the seminar for each $5 decrease in price. All of the other information stays the same. So let me remind you what that original problem said. Do you remember what it said? Someone has it written down there. It was if the price was $400, 1,000 people would attend. This is saying, hey, look, they were wrong about this. Okay? They were wrong about this. Its new estimate is that only, the other thing said, if price went down by $5, right? Attendance would come up by what? In the original problem, would come up by 20. That was the original problem. Hey, this company says $400 for the seminar, 1,000 people will show up. If they bring the price down by $5, 20 more people will come. This is saying, hey, they were wrong about that. Not 20 more people will come, only 10 more people will come. Could you redo the problem now? Okay, go. You have 3 minutes. No, I'm kidding. I'll give you like 6 minutes. Let's see if you can do that in 6 minutes. So it's the first problem we did, but it's going to be a different setup there. Yes. Yeah, do it on that same page. Just do it on either below it or on the back.
Oh, did you put your mic on?
Yes, I did. But then I'm going to turn it off again. let's take a poll here. What should the new price be? What is it? 450? Do we have anyone in agreement? 450 for the new price? Uh-oh. You agree? Okay, let's figure out what is the revenue function. How is it different than the last one? It's 400 minus 5x. That stays the same, right? But then the next part should be 1,000 what? Plus 10x. And when you multiply this out, you should get, what is this, negative 15x squared. What's the middle term? What did y'all get for the middle one? What did I do? Why did I put 15? Oh, I know why I put 15. I know exactly why I put 15, but and then what? Negative 1,000x plus 400,000. So is everyone good up to that point? 1,000. Telling you, spring break. I'm already almost there. Okay. Now take the derivative. So r prime. So this is the only difference in the problem, right? That's it. That's the only difference in the problem. All those words just to change that from a 20x to a 10x. And then all the math is different though. I mean, what happens here? You get negative 100x minus 1,000. And then you set that equal to 0. And when you solve that, you're going to get a negative number, right? Negative 10. That means that we don't want to do a price decrease. That means we want to do a price increase. So we're going to take negative 10 and plug it in here. Remember, this was the price, and this was the number of people, right, that we're going to attend. So if we replace negative 10 in here, you're going to get negative 5 times negative 10. That's going to give you positive 50. So you get 450 for the price, right? So that is correct. And then to find the revenue, you replace this with negative 10. And that's going to give you minus 100. So 900 people, less people are going to show up. 900. 900 times this is whatever. Okay. Let's try and talk inventory control.
Is your mic on?
My mic is on. Thank you. All right, here we go. Jeez. Try this. I'm going to get this eventually. Hold on, this thing is all messed up. There we go. That's the best it's going to do. Can you do me a favor and turn on the light just for a second? I think it might, yeah, that might help it focus a little bit. Okay, now try turning the light off. Can y'all see it or not? Okay. All right, let's read through this thing. Yes, I did. Thank you. All right. Inventory control. A multimedia company anticipates that there will be a demand for 20,000 copies of a certain DVD. Frozen. Wasn't that a Disney movie? I know y'all love that movie. I don't know. So you got some DVD, some popular movie. The company is expecting a demand of 20,000 copies of that DVD during the next year. It costs the company $0.5, which is 50 cents, to store a DVD for 1 year. Meaning, if they make a DVD, they need to go put it somewhere. Okay, store it, not in someone's garage, but they have to pay for some sort of storage, right? 50 cents a DVD to put it away for 1 year. Each time it must make additional DVDs, it costs $200 to set up the equipment. So when they actually are making the DVDs, they have to, hire someone, I guess, and sit them down at the computer and set up the machine, and that costs them $200 each time they do it. We call that a production run. So when they do a production run, there's a fixed cost of $200 every time they do a production run. How many DVDs should the company make during each production run to minimize its total storage and setup costs? What? Okay, so here's one idea. Okay, let me give you some possible scenarios here. Let me write down some important information. It was 50 cents, it was 20,000 copies. 20,000 copies need to be made. It's 50 cents per to store for 1 year. And what else? $200 fixed cost for production run. All right, let me get this out of here. Do you see a button on that black panel over there that says HDMI?
Yes.
Okay, hit that. Yep. There we go. All right. All right. So let's try and think about what's happening here. We need to try and figure out. Do you remember the question? I don't. Hold on. It says, how many DVDs should the company make during each production cycle? All right, so think about it this way. Let's let this be the number of production cycles. And this over here be the number of DVDs made.